Okay, let's get started. For those watching this live stream, this is a design review meeting, internal software architecture discussion today, continuing our life in the trees, looking at symbolic representations of trees in Wolfram Language, intended for the next version of Wolfram Language. So, should we get started? Where do I start here? Should I just evaluate these first few things?
Yeah, evaluate the code. And last time we stopped at tree objects and graphs. So the third section.
Okay.
So here we have two symbols. One which is tree graph. It takes a tree and returns a graph.
Okay, so we've got this rules tree concept that is going from rules to a tree. And then the question is to go from the tree to a graph.
Yes.
And this, I see, it has vertex names. So if I were to go, so if I do this, if I say tree is rules tree of that, graph is that, and if I say this, if I say graph of that, comma, vertex labels, arrow, automatic, then I'll get that.
Exactly. Yes.
Cool. Okay.
So here, tree graph is a symbol that we already have in system, but we decided to add this functionality for the tree element object.
What about the option vertex naming?
Yes, so this is something we mentioned last time. So the idea was to find a way when you do the conversion from tree to a graph to choose what will be the vertex names of the graph. So by default, it is automatic. And as you can see in the input form, you get the name of the tree nodes. If you go further down, we can change this to index.
What on earth is this? What is this graph ABCD? Those are strings, yes? No, those are not strings. What are those?
These are the name of the vertex of the vertex.
Oh, I see. Sorry, they're the actual symbol names of the vertex. Okay, so wait a minute. What is Charles's point here?
So essentially, they add a new option, vertex name. So I'm wondering how we'll work with other type of input. I mean, we cannot have
a new name. What is vertex names? What does it do? That's a new option in 11.3.
No, he said vertex naming. The option
vertex naming.
He was just adding. So I wanted to know how we'll interact with other type of input.
Wait, who's adding that? What's?
Yes, so the name was not decided yet. The idea is that we wanted something to say what will be the name of the nodes in the graph. So this is a temporary name, vertex naming.
Of the nodes in your destination graph?
Yes, exactly. Yes.
And why do we think they need to be renamed? I mean, is there a graph theoretic way of renaming them, so to speak?
No, but you might have repeated things,
yes.
like, you might have a tree with...
Right. I remember this discussion, right. In order to make it a
so, one thing that you can do when you build a converter, if you need some kind of control over that mapping, that function that provides, if you want some control, you need a function that provides that control.
No, I agree. Otherwise, we're going to be doing some crazy thing, A0, A1, A2 type thing.
Right.
But so what is the default? If I were to give, okay, so let me make this more difficult.
I mean, for instance, it could completely ignore what the node names are in the tree and just use 1, 2, 3, 4, canonical numbering, and then just purely use those as labels. That's another choice it can make.
Yes, I agree. I mean, which is not totally stupid in my view. So, okay, so there we've got one with repeated stuff, right? Okay, so let's now. So what happened there? So this didn't, what did it do? It just didn't label the ones. I see. The ones that were repeated, it didn't label. What the heck? Am I going crazy here? What did it do? Oh, because that's...
Yeah, you evaluated the same...
Yeah, right. Okay, fine.
Yeah, so by default, when it is set to automatic, it's going to try to take the name of the tree nodes. And if there are duplicates, it's going just to take the index.
Harumph.
Yeah. So I think by default, graph is using the them. So this is a depth first ordering for the naming of the vertices.
No, you give them as input. There's no choice. If you specify that tree using those names or those symbols, that's what you get.
Right. So
No, but Roger, this is the case where there are repeated values here.
I just said that there is a solution to that, and that's, in the conversion is where you can control. If you want repeated value, which is completely valid, we can have a tree with repeated, node names. The head can be the same and melt. That's perfectly valid from the design point that we do now. It's not valid as a graph. They need to be, if they're going to structurally be the same, they're going to be unique.
No, I understand, but the point I think Xavier was making is this is a depth first traverse.
No, it's coming from the input of the vertex list, the way you give it. We don't do a depth first traverse for the naming.
What do you mean?
So the way he built the graph. So if you call it, 1, 2, 3,
I see.
4, you map it 1, 2, 3, 4.
But there are some symbols that generates some graph directly, and there is an automatic naming for them. Is that correct?
You mean something like carry tree or something generates? What does carry tree?
Yes. Exactly.
So if I say carry tree of 10,2, and then I say that thing vertex labels to automatic.
But there's nothing you can count on. I mean, that's not a that's using.
I understand. Although, I mean, there would be something you could count on, which is a part numbering scheme, which is not what this is.
No, it's not.
Successive integers, right?
It's,
on some kind of traverse.
It's the graph index. Everything has an index.
Fine. I mean, we clearly need to get more sophisticated about re-indexing graphs when we do graph substitution and so on. Has that been looked at yet?
I don't know. We don't do graph substitution. What are you talking about?
No, I know, but we've talked about design for graph substitution.
Okay, then that doesn't exist yet.
No, I understand that, but when we think about relabeling graphs, graph substitution is one of the applications for graph relabeling, right? And so, in particular, something where a node you give birth to nodes, right? And every time you give birth to a node of a particular, like every vertex could turn into 3 nodes, for example.
Sure.
And then we have to have some scheme, which I don't think is completely unrelated to the vertex renaming scheme. Okay, so the proposal here, which was on the table, was to have a vertex naming function. Are we going to call it vertex naming or vertex naming function? Anybody? I mean, and the idea is that is the thing which maps from what? From the part number in the tree? This seems like a very general name for something that is, I mean, in a sense, this is a very specific thing about tree graph.
Right. That was my point, that you cannot. It's specific to actually your tree element. It's not specific to tree graph.
The relabeling.
Yes.
What's the other case where you make a graph from a tree element tree? I mean, isn't this the function that makes graphs from tree element trees?
This would be tree graph only, yes.
Right, I know, but I'm asking, is there anything else that makes a regular communal garden graph from a tree constructed from tree elements? Because Charles was making the statement that this is really associated with the tree elements.
Yeah, I agree.
And I'm wondering if that is true, because the graphification of the tree, maybe there's only this one function which does that graphification.
We discussed at some point having an expression graph, which may run into the same issue.
Yeah, it will. Don't we have an expression graph here?
No, here we could do expression tree and then tree graph.
I see. Okay, but expression tree we should have, and it will run into the same issue. Didn't Georgia work on an expression graph thing?
Yes, she did. Yeah.
And what is the status of that?
So this is very similar to what we have currently for expression tree.
Oh, I see. Expression tree.
But here we actually return a tree element object rather than a graph.
Okay, but so if I do an expression tree of something like this, okay, then I get that. And if I now say tree graph of that, and then I say graph of that with vertex labels, what is going to happen? I see. So it didn't even make an attempt. Even if this had, I see. I mean, it's implausible, but it could conceivably have had unique labels for everything here.
Perhaps this is a case in which we have to separate the name of the vertex and the label of the vertex.
Okay.
Do you have a separation for that, Xavier?
I think, well, yeah, but there was some issue. Not for tree graph, sorry, actually, not for tree graph.
Okay, so wait a minute. What is the difference? Okay, so name of the vertex in the original tree element, right? There is a name sub-element in the association that is the vertex data for that, right?
Yeah, yes.
Okay, so what you're saying is that name is not adequate to be the name for the graph element. By the way, we're getting some echo on this line if somebody is able to adjust themselves. Okay.
Yeah, so the issue was when we have nodes with the same name. Yeah. So this was the main idea of having some option that can control this.
I mean, I think the option should be attached to your tree object. And when you do a tree graph on that, then vertex label automatic will interpret it based on that. But it shouldn't be attached to tree graph.
Well, but Charles, you're never going to think of this. I mean, there's no obvious place to attach it to the tree element stuff.
I thought it carried options, general options, don't it?
It does, but this is a global issue. I mean, doing vertex naming based on index or tree path is a global thing for the whole tree.
Perhaps what Charles is saying is that the graph should have names which are basically the positions, which are uniquely defined, and then the graph automatically should pick as a label the names. And then it doesn't matter whether they are repeated.
Right. I mean, our first prototype for expression graph was essentially doing the same too before Georgia started to take it. So essentially, we use position, and then you play with option to manipulate what you want, the label or the name and such.
Okay, so your proposal is that tree graph of the rules tree just blows away these names here, but puts in the names as labels for the graph. Is that right?
Yes.
I think so.
That makes a lot of sense to me. A lot of sense.
Okay.
That seems like the right thing. And if you don't want the names, you just say vertex. I mean, in other words, if you want vertex labels, you put in vertex labels. If you don't want them, you don't. Yeah, so I think that's fine. You can say vertex. Now the problem, yeah, right, that should be fine. So you're putting them in as vertex labels, correct? In the graph created by tree graph, there is a setting for vertex labels which carries over the names from the original tree.
And
correct?
then you can happily have things repeated, and it's just fine.
Yeah, it's fine. That's the correct design. Okay.
Okay.
Happy with that?
So what will be the name of the vertices? Do we index them for the graph?
I think we should index them like this.
Okay.
We should index them on whatever your canonical indexing sequence. Now, we can talk about that sequence, and Roger or anybody else, do you want to discuss what that sequence should be? I mean, this is a depth first traverse through the tree, isn't it?
I think it's the input order. I think it doesn't yet know the structure when it picks the index.
But so what do you mean by input order?
because you're gonna, if you give a set of rules, if you give a set of nodes and then set of rules, there is an order in which when you
I see. But that's determined by how Xavier generates that order from rules tree.
Correct.
Exactly. Yep.
Okay, so what I'm asking you then is, from rules tree, you're doing a depth first traverse to generate that order.
But probably it shouldn't matter as long as all the labels have different indices.
No, I understand it doesn't matter, but we might as well get it as right as we can. That seems like a sensible ordering, right?
But I was just thinking that carry tree just below is actually doing a breadth first order. So maybe I should follow this one instead.
Well, and actually for expression tree, that was something we picked because it's kind of for roughly the evaluation order too. So
which one, depth first or breadth first?
Depth first.
Okay, but notice that carry tree is using breadth first traverse.
Yes, that one was just a choice. I don't think it was. I mean, we did something special about it.
Okay.
The other possibility is to give a name which is the position, and the position is uniquely specified.
The index that are used by graph, you shouldn't put too much into them. The only property that they need to satisfy is that they're unique.
Yeah, fair enough. Okay, fine.
There's no, because you're going to mangle that tree in all kinds of ways, when you transform it and stuff.
Fine. Okay, so the only issue is, in the case of an expression tree, there is a certain argument that we should give the part number as the default name of as the default identifier for the elements here, right? And so the question now, the only question that we have really right now is, again, in your list here where you give the index or the tree path, you could conceivably give the tree path instead of an index here. I don't know. What difference does it make? I mean, I think we should just give the index with the depth first thing, and maybe subsequently we can figure out an option to change that if it seems important. Makes sense to people?
Yeah.
Okay.
I think some use cases will then say, hey, it would be cool if we could do this automatically, because there's something that's particularly useful and it's kind of ornery to do.
Yep, I agree. All right, let's keep going here. Okay.
Yeah, so here this is just to show the reverse operation.
What is the graph root? Is that an option in graph at this point? Or is that a new option that you're adding for the sake of being able to disentangle these? Where did graph root come from?
Is an option in graph which is not documented. It when we're working on actually having rooted tree and rooted graph, but since we didn't propagate the functionality everywhere, we really haven't documented it.
Okay. Do we like the name? It worries me when we have square roots of graphs and goodness knows what.
Well,
I mean, wouldn't it be better to say graph root node or something, or do we not say graph root vertex?
Yeah, probably graph root vertex is better. It's more precise that it's a vertex.
Okay. Can you have, and that does seem like a useful option. I mean, it's an option relevant for drawing layered graphs, right? And it's the thing when we were talking about in that equational proof business, when we were talking about how to determine what the roots are in a layered graph, this would determine it, right?
Right, and it affects actually a lot of things like, breadth first, depth first, traversal, because you need to have a root, layout, and such. So.
Okay, well, so graph root vertex.
It doesn't, but it gives you a default that you can start on if you don't give it, right?
Right, yeah.
Okay, so we agree, graph root vertex. So can we rename, and we could go ahead and document it, I guess.
Okay.
Okay, so let's take a look here. So if I don't give the graph root here, what happens?
It's going to decide which node is taking to take as the root. So it should be the first in the list, so we get the same output.
Okay, but if I were to relabel, if I were to do a rotate right or something here, oh yes. Wow, that happened to give that. That's going to be confusing here. Whoa, why did it do that? Does it know? What does it know here? Who figured out that the root node is A here?
Well, it's looking at the, oh, maybe no, maybe it's actually looking at the, yes, it's looking at the edge, I think, first, rather
Okay,
than
so let's say that I add here a C goes to C edge. Okay, some random thing. And now I say graph tree of that.
Okay. That's not a tree.
Yeah, I understand. It's not a tree. Why don't we just say position 1? Why are we saying it that way? We should just say, I mean, the fact that it's a position 1 is, this is too it's too kind of pseudo-precise. Jose, help Xavier clean up this message.
But we use that quite a lot. I mean, that type of structure.
Yes, but only when there are multi-argument things. And
oh, I see what you mean. Yeah. Okay.
I mean, you kind of know. And also, we're not supposed to say should be a tree graph Q object. It just says is not a tree.
Okay, we'll improve that message.
Okay. Okay, all right, let's keep going here. So what is this now? This is a rules tree. Okay. And then that becomes the tree graph of it. And then we have the graph tree of it. And all of those properties so that raises the question, if you have a graph and the nodes aren't named, what happens as you make a graph tree from an unnamed graph, if you understand what I'm saying? So let me.
Well, they always have indices for sure.
Yeah, I understand. But so if I do carry tree 10, 2, for example, and then I say graph tree of that.
Yeah, so the warning will be removed, but it's taking the indices here.
Okay, that's not completely crazy. Except, what is this weirdness? Look at the ordering there. Let's take a look here. Okay, there's our carry tree. And for some reason, it did a flipperoo here.
Yes. This is a bit difficult to control, actually.
Okay, explain.
Well, it really depends how the rules for the edges are given initially in the graph. So it's going to read each of them one by one in the order they are given. So we may not end up with the same.
But is there a canonical ordering? Go ahead.
Well, it's a layout issue. I noticed that a while, but you don't yet have a perfect solution. Sometimes, with the adjacency matrix or similar adjacency matrix, we don't control exactly the rotation of the stuff. It's a layout for graph issue. So that's a non-issue.
I see. It's not an issue of the numbering.
No.
Oh, I see. Yeah. You're right. The numbering is correct. The 2 is part of the bigger branch.
Yep.
Okay. All right. Okay. I get it. I mean, Charles, there might be an argument to take a little glance at the actual naming of the nodes and see if there's a lexicographic order that will disambiguate during layout. Or is that nuts?
Well, that makes sense. The case where there are, pure and there's numbers, right? Sequence of integer. It probably makes sense.
Even if it's lexicographically orderable. I mean, even if it was strings, it's not completely crazy. It would at least give some canonicalization to the whole thing.
Right.
Okay. All right. Any other issues with graph tree? This looks great. I mean, okay. Now you're talking about undirected graphs.
Yes.
Okay. We already talked about that in a sense. We're given undirected graph is unspecified. Okay. But you can determine the root vertex, right? If it is a tree, you can determine the root vertex. Yes?
It may not be unique.
No, that's what I'm saying. This one has many roots.
You could start anywhere, yeah.
Okay, well, you can determine a root vertex, right?
Yeah.
But let me take an example. So if I'm not mistaken, find spanning tree is the thing which will give you a tree associated with one of these graphs. Is that correct?
Yes.
And so for example, if I take, can I get a random Cayley graph or some other cool thing? What's a good graph, guys? Just give me a graph.
Random graph.
I don't want a random graph. I want a graph, a random named graph. Whatever. I'll take a random graph.
You said you wanted a random graph.
I know. Okay. All right. There we go. So find spanning tree of that. How can it have disconnected vertices if it's a spanning tree?
It's a spanning forest.
Yep. So when it's not connected, we keep those edges.
You span each component.
Vertex, yes.
Okay. All right. Well, let's go like this. Blah, blah, blah. Okay. What do we do here? So we say connected components. What we would have to do then is to say connected components of that line, right? Wait a minute. How do I do this? What is the thing for just getting the graphs?
Graph connected component. Oh, connected graph. I think it's connected graph component. Sorry.
Blah. It's kind of messy. Okay. 1250. Okay. Great. By the way, Charles, are you doing this thing of sizing the graphs based on their content?
Yes, you're working on that.
You are working, but it isn't. But that isn't something that has been done in this output. Is that correct?
Yeah, it's not done.
Okay, fine. Do you have reasonable heuristics for it, or do we need to talk about them?
Kind of writing prototype, and when I will have something ready, probably have a meeting and discuss about it.
Okay, fine. All right, so boom, let's graph tree that. Okay, so the first one is happy. The second one, should that work? I think it probably should. What's wrong with a tree of one node?
No, yeah, it should work. I'm not sure what is happening here. Yeah, it should work.
Okay.
We know what the root is.
Okay. All right. That's just a bug, probably. All right. I'm pretty happy with graph tree. Any further issues with graph tree? Nope. Okay. Let's move on. Okay. I mean, we got quite a bit more to do with those tree. Okay. So tree rules.
Yes, so the idea of tree rules is that you give it a tree and it's going to output the rules that make the tree.
Okay. What is this complicated thing here?
Yeah, tree vertex should be removed. It's really tree element, but here it's working with tree vertex.
Okay, but this is simply you specifying a tree.
Yeah. It's specifying a tree, and in the rules that you get, you can have actually further information on the node. So for instance, you can see that R goes to, and you have something which is the style of the vertex.
I don't understand that. What is that thing? Is that a tree element?
Yes. This is the last node that you can see just below R. It's a red node, yeah.
Okay, so if I look at the input form, this is a bunch of tree elements.
Yeah, so here again, it's tree vertex, but it will be changed to tree element, but yeah, this is the case. So the main idea is that you may want to add some properties to the node.
Okay, so this is a decorated, so that your point is, when it is just a name, when the only thing in the tree element is a name, you strip it to just be the name in the tree rules. And
yes.
When it is decorated, you have the full tree vertex.
Yeah, exactly. Yeah.
Okay, I would argue that we should have some function that determines what happens. That is, this is the automatic setting, but I can imagine places where I would want to fluff the tree vertex, even if it has no, or tree element, even if it has no extra properties, to make it of consistent shape to the other things. And I can also imagine cases where I would want to just drop the properties. Am I making sense?
Yeah, so here I was using a second argument in tree rules. which is basically the key.
Oh,
So we
that's
are going.
nice. Yeah, that's nice. So I mean, automatic for that would represent, or the one argument form, or automatic. Yeah, okay, you've already got this problem solved. I agree with this solution. And the default here is basically name. Is that right?
The default is
No, the default is this automatic behavior which fluffs
everything.
out, if you need to.
Yeah.
Okay, so wait a minute. The only way to get everything is to say automatic, or is it all here?
I think it's automatic. I would have to check again, but yeah.
3 element. You say there are 3 elements, and you get 3 elements back.
That's a little weird, because remember, that's usually the key, like the property name. By the way, that should be allowed to be a list of keys.
Okay. Yeah. Okay.
Okay, let me suggest 2 other settings. Automatic means do the stripping thing if it's just the name. Okay, and all would mean just come back with the full tree element in each case. Am I making sense?
Yeah. Okay.
Xavier or Jose, have you guys looked at, and I think that this is something we could do here reasonably, is to have sort of an elision behavior for the layout part. So we have like a cloud there in the middle, and you can still see the leaves, or 2 levels down below the cloud or something like that. However we decide to align some part of the graph.
Yeah, you're suggesting that you drop the labels, you drop the decorations here.
Yeah, but the other thing, I mean, even more drastic, drop whole subtrees in the layout that we look at them, because then we can have a more surgery-like operation to see what part of the structure do I really want to kind of see. I mean, it might be a future type of functionality, but I think that would be kind of really powerful, particularly when you don't work on just toy-sized trees.
Right, but you're suggesting this as a display mechanism, or you're suggesting this? Yeah.
As a display mechanism, but if we are very happy with the display mechanism, that might be something that we actually encode in the structure so that it's the default display mechanism. So you don't have to specify it every time.
Well, so are you suggesting that you be able to click to, open a subtree?
Oh, eventually, but I was thinking of even programmatically, or markup-wise, encode that what things are visible and what things are not.
Right.
Because what it would probably allow one to do, but I guess we have to experiment with it, is to skip many layers of a tree and then sort of start seeing structure in the beginning, start seeing structure at the end, and it might be quite powerful.
Well, okay, so
very
look,
insightful.
There are 2 places which are similar to that. One is expression folding, right? Code folding and expressions, which is a similar kind of thing.
Yeah.
And another case that I would potentially argue for is graphs. Take this subgraph and squash it, which is essentially what you're doing in like the system modeler world. You're essentially saying, take this subgraph and make it a single black box, if I'm not mistaken.
We also have our model
but the
of cells.
thing is that it's way more complicated for graphs, and in the case of system modeler, it's left to that's first of all quite elaborate, and it's sort of restrictive of what you can and cannot do. But for graph, to specify what the interface is, for a general graph, it's way harder than for a tree.
No, I understand. We've also got this in NetGraph and in neural networks. We already have a mechanism there for displaying, right? I mean, you can display the, when I generate a neural net, right, from NetModel, for example, if I look there, let's do this one. If it will load. What the heck is that? That is a new bizarre thing that I've never seen before.
So it's just a chain. That's also a tree, if it's just a chain.
No, but it's not, because it has these net graphs underneath it, see?
Oh, I see.
Which have all kinds of junk in them. What is this? Sushma, do you know what this is?
The summary box. That's something Tally worked on, and he wants graphic design to look at it, and we will do it as soon as graphic design gives us a design for that.
Okay, I think what he has there is entertaining, whimsical, and crazy.
Okay.
Those are the three adjectives I would use.
Okay.
Okay. Well, I think this is this whole question about folding and elision is one we should talk about. Can we put that, let's separate that off from this.
Yeah, I don't think it's necessary, but I think it would be a good
It will be great. Yes.
plus.
Okay. Here, are you really giving a missing without anything in it?
Yeah, I was wondering which string we could put there.
Well, don't we say key missing? Don't we say, isn't it in the, go ahead.
I was thinking of putting actually the name of the key that was given in the...
Isn't that what naturally happens? I mean, if I'd give an association and I say, some key here, A, don't I get that? Key absent, comma, A?
Yes, but one issue actually was that if we take it again, this rule, and we use rules tree on it, it might interpret the missing as vertex name, and it's going to go down in the expression of the missing, if you see what I mean.
Yes, I see what you mean. That's horrifying.
Yeah, so this was the issue, or maybe we can make rules tree itself. Well, no, we can't. I was saying we can make it not looking inside the missing expression, but...
Walk me through this again. So a rules tree, why would it go inside? I mean, it's only looking for rules. The expression tree might go inside, but rules tree will just look for nested rules, won't it?
No, yes, that's correct. I've been confused. Yeah.
Hey, let me ask you another question. What about a two-way rule? What are you doing with those? Are you interpreting a two-way rule in any useful way for tree rules?
Not for the moment, no.
Is there something it could mean? I mean, it's more like a graph.
Undirected?
Yeah, right. But I mean, what does that mean in a tree to be undirected?
But trees, undirected trees are perfectly well defined.
Fair enough. Then maybe you should just treat two-way rule as the same as rule for these for now, Xavier.
Yeah, I will also add undirected edge. Actually, I don't think it's working now.
Fine. Okay, so what are we saying here? So right now we don't care about this missing, and it should just be a key absent missing. Is that correct?
Okay, yeah.
Anybody object to that? Anybody see a problem with that?
No. Okay.
All right, let's go on. Tree insert. Okay, so we started talking about this last time, as I recall. And the concept here is
you have a tree element expression in the first argument. The second argument is a tree object you want to insert. And the last argument are the positions. So
yeah, it's sort of a shame because in a sense it's much cleaner if you can give a list of rules saying insert this in these places. But I guess that would be more like a tree replace part. Do we imagine a tree replace part?
We could do that, yes. Yes.
We can think about that. I'm not sure it's useful. But tree insert, although maybe it seems like a more natural syntax than this. Okay, but so let's take a look here. So this is saying, given the particular tree path, insert a node. I am very confused here. Insert a node to become that tree path. Is that correct?
Yes. So, yeah,
but if the tree is labeled by an association rather than by lists at every level, what then happens?
So here it will go to the first
position in the association, but what's its key? Did you understand what I'm asking?
Yes. I'm trying to. I don't think I actually.
But if we have an association, we still have a notion of what's the first, what's the second, right?
We do.
Yes, but there is the issue of what will be the default name for the key. Yes.
Right, which has to be non-overlapping with anything else. And what on earth do we do if we wanted to do it based on the index number, but there happens to already be an association element whose key is 1, for example, then we're in a bad shape.
Well, don't we have to displace them as we do with expressions?
No, but if somebody actually had their association with 10, 11, 12 as the keys,
Mm-hmm.
it would be pretty obnoxious of us to just pick up those keys and change them. I mean, one assumes they were there for a reason. Or worst case, we fill in a lot of nodes and they just had number 101 was there, and that 101 meant something completely different. Who's got a good idea what to do? Okay, so what should we do?
But I'm confused. So you're talking about the situation in which we have 3 keys and one of them happens to be 2. And then we say insert at position 2.
No, I'm not saying that. I'm saying that.
I think it should be an error. But if we have other numbers and we say insert at position 3, it will count the 3rd key in the association and not just insert a number 3.
We have several other people here who have been remarkably silent, but maybe they have no opinion about this. Okay. I'm sorry. Do you think you have a solution here? What are you saying?
No. I'm trying to say that we do the obvious cases, and in the ambiguous cases we give errors.
Well, one possibility could be to give the key in the second argument, maybe. So key goes to 3 elements, blah, blah, blah. If we were to insert in an association.
But what if the tree element itself wants to be the rule A goes to B or something?
But don't we have this problem already in association itself, inserting in an association?
Sure, we have all kinds of things that deal with, doesn't association have, in association, don't we have a whole bunch of pruning options and things? How does it work?
Well, does insert work in association?
That's a very basic question. Let's answer that question. Okay, so let's try, let's build an association. A goes, let's say, A goes to 1, B goes to 2. And let's say insert X at position A. What?
Yes. So for an association, you have to give a key value per, probably. Yes.
Okay. Interesting. Okay, X goes to 6. And what is it doing for the 3rd argument there?
So it's really before the key named.
Oh no, you know what that's doing? That is saying where in the, look, watch this. See? That tells you the sequential position in the association at which the thing will be inserted.
Oh, I see. So if you said B, it would insert it in the middle.
That's right. But if I do this, if I say B arrow 6, it's going to overwrite. Look, tree insert should do the same as insert does. And it should insist in the same way what you were basically saying, namely that the second argument, in the case where it's inserting into an association element, it should go ahead and insert it at a position corresponding to the last argument with an association form that is this. Now, if we're doing it with multiple things, I'm a little bit confused what happens if we have multiple elements. And I think we should look at what insert does in the case of multiple elements there. Get what I'm saying? Because I think that looks confused to me. I mean, if you say multiple positions there and you have an insert and you say B arrow 6 at positions, 3 and 4, for example, that's even more confused. Let's do
one, yeah.
Oh, I see. But what it's doing is it's just overwriting. All right, I think tree insert should follow insert.
Yeah.
Okay, let's continue. We have quite a lot more to go over here. Let me just take a look.
Yeah, so here you give a tree and you give a rule or a list of rules to replace a three-element expression to another one. So we could, yeah, I was wondering if we could also merge this tree replace part that we just talked about.
Yes.
With tree replace itself, actually.
Okay, so let's look at tree replace here. So what you're saying is that this is taking tree element with name Z, although hopefully we can just say Z here.
Yes.
What on earth is this? That's a, oh, I see. That's itself a rules tree. I see. So this is saying, now if the left-hand side here is a subtree, or is this just a single element that we're replacing in tree replace?
It's a subtree, yeah.
But a subtree as in you label a subtree by its top node.
You will have to give all the subtree actually. So here
Why?
is a leaf. So it's basically a subtree.
Why do you have to give the whole subtree? I mean, if you're replacing, I mean, how do you re-glue? Let's say I replace this node D with something, right?
Yes.
Let's say I replace it with a two-legged animal, right? How do I re-glue this thing onto the two legs of the animal?
Yeah, this was the issue. If you replace D by another three-element expression with children, there was the issue of what do you do with O?
I think you get rid of it.
I see, okay.
I mean, I would have thought that this is a subtree replacement thing, and that you go to a particular node in the tree, and then if you really want to replace that node, you know, you extract the subtree, you do what you want to do with the children, and then you reinsert as the subtree the thing that you got. You get what I'm saying?
I see. Yeah.
Anybody else want to comment on this? In other words, that tree replace is a subtree replacer that takes tree. Now, the question is, does it take a tree? You know, is the first element a tree name, which might be non-unique, right? And then it would be the analog of replace, presumably. If I say replace of x, y, x, x, x goes to A, what happened there?
At level 1, yeah.
Okay, fine. So that's the analog of tree replace. I would have thought tree replace part was the one that would be, well,
I'm a bit confused here. So if I remember correctly, what we wanted to have is a pattern on the left. The left-hand side has to be always a tree element, so that if we say C underscore, there is no doubt about whether we are referring to the name only or the full tree element. And then we extract parts from the tree element and put them back on the right-hand side, if needed.
And what is the canonicalization of the tree element that's used for the pattern? But I don't understand, because there are two cases that we're interested in. One is replace the subtree at tree. I mean, maybe this is irrelevant. At tree position, we have a tree position function, don't we?
Well, but if we have a tree element data subtrees, we can have a pattern that takes the subtrees and puts them back in the right hand side. So we reconstruct the subtrees, and then in the process we change however we want the data.
Right.
So here we are entering again the area of patterns, of tree patterns, which is difficult, and we'll have the precedent of graph patterns. So we are.
We do not have the precedent of graph patterns.
Exactly. So we have an unexplored area here, which is difficult. But we want it to be simple and just have tree element on the left-hand side always, and you extract the parts that you want from it and put them back on the right-hand side, and that's it.
I don't think we can solve this problem in this moment here. Let's just take a quick look forward at these things, and we are going to have to meet yet again about trees. But let's just see if we can. Okay, I consider this a somewhat unsolved problem. I think we need to look at it more carefully.
Yeah, that's more difficult. Yes.
Okay, tree extract. That has a path spec. And what are you proposing for the path spec?
So here we have this problem of the relation between part and extract. And we wanted to have a design that mixes both. So we can have a list of arbitrary parts. And that's the idea of tree path. So tree path identifies a single position inside the tree, and a list of tree paths is a list of positions inside the tree.
Okay, what if the branches at a particular node are labeled by keys in an association rather than sequentially?
The tree path can take the keys as well.
Okay.
So it can take numbers or...
So wait a minute. So how does it disambiguate between children and a key?
There are some keys that are
special. But look, if we say generation, I see. So you're saying generation arrow 2, meaning 2 generations back or forwards?
Forwards.
Forwards, yeah.
I think it has to be future generation versus past generation, doesn't it?
Yes. Why don't we accept negative as well? Sorry.
Yes, I will.
Yeah, so long as we can remember which way round it is.
Right.
What is an ascendant? You know, I have to say, my thing would be to call them successors and predecessors. I think those words are extremely obscure.
I see.
I mean, ascendant, you know, strikes me as being, you know, it has some kind of faintly, you know, when you know, Venus is in the ascendant or something, or Capricorn is in the ascendant. I don't even know what those mean. There's some kind of astrological, you know, overlay. So I think those should be predecessors, because I think predecessor is very clear.
Mm-hmm. Okay.
Predecessors. How can it be predecessors? It's predecessor, right?
Well, all of them above in the tree.
I see, but there's also predecessor, which is just parent, right?
Yeah.
Okay, predecessors and successors, which is equivalent to subtree.
Yeah.
What is the name of the predecessors in a tree? I mean, isn't there another name? Go ahead.
No, not really. A subtree is a single tree element containing things. Successors is a list of all the successors. This is a slightly different thing.
Okay. Possibly that. Okay. All right. So what you're proposing here, oh my gosh, it's complicated.
Yeah. So here we are trying to mix the power of the part specification and the extractor specification together with extensions that we have seen in things like XPath, etc.
Okay. Well, let's look at it for a second, but let me just understand this. What is this? Querying a subtree. Okay. There's our subtree.
Yeah, so this is a basic version, which will do basically the same thing as tree extract, but as sub-values of the tree element object. So you can specify the position.
Why do we need the key wrapper there?
If it's a string, no, it should not be
necessary, right?
I think we try to imitate the data set here, right? Sorry?
Yes.
Yes, exactly. Yeah.
And so it also has a select mechanism?
It does, yeah. No, maybe not implemented for the sub values, but yeah, it will have that, yeah.
Okay, so this is encouraging. So we're getting close to the end here of this design. So the one thing that is really complicated is this tree extract thing.
Not so much extract as the pattern, the replacing. I think the replacing is more difficult than the extraction.
Okay, but if you've specified, so, but the replacing is going to require, it's an extract and insert operation, isn't it?
Well, no. One thing is replacing by name, another thing is by position, like replace part. Replace part is easy once we settle on the language for positions. But
Yes.
the look for something of this structure, that's the difficult part. Like
If it's been canonicalized as a tree element, why is that so difficult?
Well, it's how we use patterns and whether the pattern refers to the full tree element or only the data, whether we allow pattern on the decoration options, this sort of thing.
Right.
I mean, it's not even clear whether we will need eventually a tree element pattern.
Sorry, I lost focus here because I realized we're late for something else. You know what? We need to loop back, another meeting. Let's start with this question about tree paths. But I think other than that, we are in pretty good shape here. Yes.
Okay. Mm-hmm.
Xavier, you agree?
Yeah.
Is anybody? I mean, this is going to require our full team, I'm afraid, to talk about this. So we'll have to wait until after Thanksgiving, which doesn't give us a hell of a lot of time to get this stuff finished. Unless people are around tomorrow and we want to try this tomorrow.
But what do you mean finished? I mean, well, the plan is to have this as a prototype for some time, not in 11.3, certainly.
All right. Okay. That's a shame. No, couldn't we at least have it be a loadable package in 11.3?
I'm not sure. I think this is going to be fundamental functionality, and it's worth having some more runs.
For our own internal use, let's have it be a loadable package, just so we can play with it, even if we don't document it.
We're planning to have it in xkernel. Is that enough, so that we can all play with it in xkernel?
Be even better if it was in the main thing, but as an undocumented, unloaded package.
Mm-hmm. Okay, we can do that.
Possibly even a packlet that could be updated. All right. So several of you, I think, are in the next meeting, which will start in about a minute here.
Mm-hmm.
And for those of you who are still surviving on the live stream, we might see you in the next episode. Same channel, same whatever they say. I don't know what they say. I don't watch television. Maybe they don't say the same thing anymore because it's all expected to be streamed or something. Okay, talk to you all soon.
Okay.
Bye.
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 Bye.